universe. What is a universe? Okay, we've been dealing lately with the universal movie, as I call it, and it allows us to distinguish, especially this concept known as the universal movie. I call it a tool. It allows us to distinguish between static concepts and dynamic concepts. Okay, and here it is. Just for went on the other side. Give me a second here. These are so touchy sometimes. Okay, so this is the universal movie, and what are we showing there? Well, we're showing frames of the film. You got to think of the universe as, if you take a snapshot of the universe at any point in time, you got God's camera. You can make it a three-dimensional frame if you want, no problem. Okay, this is God's camera, so he can do that. So we have a three-dimensional movie. Okay, we film it, and we just take one frame of that film. Well, hopefully nothing will be moving within that frame. Okay, all you have there is every atom in the universe. Some form part of planets, others of stars, of asteroids, or whatever, gases. So you have every atom in the universe is standing still. Okay, we got that? That's what's in one frame. Okay, and so all we have is existence. All we have is location, right? Every object at a given location, and there's a separation between that atom and every atom in the universe. That's all you see in the movie, in the single frame. There's no motion in that single frame. Okay, that's the notion. And the question is, where are we going to put the universe? Are we going to put it as a static concept? Is it a physical object? Is it a dynamic concept? What is a universe? Okay, you will hear people talk about the expanding universe, about the curvature of the universe, right? Whether the universe is finite or infinite, you get all these. So people treat it as a physical object. And the question is the universe a physical object? Is it a container? And if so, what's outside of the container giving the container shape? These are the questions. These are valid questions, at least in physics. Okay, so what is the problem? The problem is we have a difference between physics, real physics, and what they call mathematical physics, which is mathematics, which is not physics at all, which is not even science. It's just math with irrational explanations. That's all they have, irrational physical interpretations. Okay, and so here we have the difference. You see them side by side, how each of us looks at the universal movie a little bit differently. Mathematics, they emphasize experiment and evidence. And physics, real physics, science, emphasizes reasoning. Math what they do is describe and predict. They use equations to describe, okay? Numbers, equations, etc. And in physics, we don't use equations at all. We just want to explain qualitatively how this universe works. Math emphasizes persuasion, convincing, converting, recruiting, and physics only wants you to understand. Once you understand, we're done with physics. What continues is religion, which includes persuasion, convincing, converting, and recruiting. Proof, knowledge, and fact, those are words that the mathematicians use. In science, we do not use those words. We use causes and mechanisms. That's what we want to understand. We want to know how gravity works, how a magnet attracts another, how electricity works, that kind of stuff. So for that, we need causes and mechanisms in order to visualize mechanisms, understand them, right? We need objects, but that's not what math uses. Math uses mass, because they're interested in the numbers, in the quantities, in the units, stuff that they can put in an equation. They can't put the word object in an equation. They can't put the word star in an equation. They can't put the word planet in an equation. So what they do, they put the mass of the star, the mass of the planet. Okay, that's what they're interested in. So they're interested in calculations, and that has nothing to do with physics. In physics, we need to explain the mechanisms. We want to understand how this universe works. And here we are 10,000, 20,000 years later, right? And nobody can tell you how gravity works, how a magnet sticks to your refrigerator, without using concepts. And what they do is they always use words that represent concepts such as field and mass and charge and those kinds of words, energy. Anyways, Observation and measurement, that's what math does, and emphasize that we do not use measurement or observation. We do not use our eyes. What we use is the mind. We use our brains, and what we're trying to figure out is what exists out there. Okay, and again, you can use the universal movie to find out what exists simply by, if you could take a snapshot, that's what exists of the universe. That's what exists, and you would find every atom somewhere in the universe at a given separation from all others. That's what you would find in a single frame of the universal movie. And so we do not have to have observation for that or measurement. This is a conceptual issue. Mathematics, they emphasize numbers and units and number lines. We don't use those in physics. We use dimensions, coordinates, and vectors. Like with height, longitude, altitude, and latitude. And the vectors are depth, breadth, and elevation. The mathematicians, they like displacement and distance travel. They have to have something in motion. All their concepts, by the way, are dynamic. In physics, we first have to determine separation, distance. Distance is just separation between two objects. They use words such as energy, force, field, and charge. And we do not care about those. We care about the physical mediators. We need to identify the physical mediators. And if we cannot see or touch them, what we do is imagine them to find out how Mother Nature is doing her mechanism. Okay? And we get to the real crux of the issue, which is time versus location. Okay? Mathematicians emphasize time, and physics emphasizes location. So what is the issue? The issue is that, here, I'll put it in a little picture for you, okay? Here you have physics, okay? And we have a single frame. That's all we care about. We want to know what's in that single frame. That will tell us what exists in the universe. We just stop the universe. We take a snapshot, and we can see every little atom in the universe in that snapshot, okay? That's how good that camera is. That's how good the frame of the film is. We've taken a snapshot of the universe. Now we're going to inspect a single frame. Okay, there's nothing moving in that frame, hopefully, unless you drank too much beer. Okay, and so we can figure out what exists. That's what's in that frame. Existence. That's all you have there. You have location, you have distance. All these static concepts can be found within that single frame. On the other hand, mathematical physics, mathematics, right? They're interested in time. So what they look at is many frames, okay? And so they tell you that, time at one side of the universe is different than time at the other side of the universe. And that is somewhat of a problem because, we're talking about location. And hopefully in a cross-section of time, cross-section of motion, right? Single snapshot, where we only have location, a static concept. All we have is, every atom in the universe has a given location with respect to all others in that single frame. Okay, that's what exists. But when you talk about time, you're talking about, hey, I'm going to be traveling, I'm going to be measuring, I'm going to be observing, I'm going to be doing all those things that mathematicians do. I'm going to travel to the other side of the universe, and it turns out that if I travel faster, time has a different value. Okay, and there's a different time on the other side of the universe depending on how fast I travel, and they get into all this nonsense, and because of that they get into weird conclusions like, you can travel back in time or forward in time, and this is more or less what's happening. Let me put it here for you. Here it is. Keep an eye on this. You leave the present and you can go to the past, okay? And so what's the issue? The issue is that your rocket ends up in some kind of frame in the past, they say. In other words, what they think is happening is that, or at least what they believe, is that Mother Nature or Father Universe or God or the devil, one of those guys, collects all these frames of the film, okay? And when you leave the earth, you're going to go into the past, for example, right? And you're going to fall in one of those frames because Mother Nature preserved it in her file cabinet for you. Okay, this is what they think, because they're talking about math. They're not talking about real physical reality. I mean, what these people think is that the past is somehow filed. and there's a physical past that you can go to with your rocket. Okay, and yeah, what happens is you can end up killing your grandfather. Okay, so this is what they allow you to do. Not only that, what you can do is go to the future, and in the same way, in other words, not only can you go to the past, but you can go to what has not happened, all because of this time thing. And the question is there a file cabinet with all these frames of the film, three-dimensional frames, right? With all the objects there for you to land in the future. Okay, and again, here it is for your visualization. You're going to go from the present, you're going to go to the future, okay? And you're going to land inside some kind of frame that Mother Nature has in the future. And so what happens is you're going to jump into that frame, more or less like Mary Poppins. I don't know if you saw the movie, but you should. And you'll see this, okay? Here it is. And they're going to jump into a frame of the movie, okay? And they're going into this fantasy land. This is what the mathematicians are telling you, okay? They actually believe that this is possible, that these frames are available for you to jump into, go into the future, the past, because these frames exist, okay? They're there. And they're not just, history. They're solid. It's like there is an earth with that frame of the film, with all the locations of every atom in the universe, and you're going to that frame of the film, three-dimensional God's movie, right? Here we're talking about, right? And you're going to land in there, and you're going to do like Mary Poppins. You're just going to jump into the frame, and there you are, And this is what they believe. And they say it's not a religion. Okay, so we look up, what is this thing we call universe? Is it a physical entity? Is it a concept? What is it? And it turns out, none of the, think tanks out there, the important ones, the ones that are official for physics or mathematical physics, right? None of them tell you what a universe is. The closest one I could get to is Wolfram, Eric Weisstein's physics site. And this is what you'll find. You'll find the word universe in there, but they don't define the word universe. What they say is the age of the universe, blah, 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 blah. Who cares about the age? I need to know what the word universe means first. And they don't define that word. And what you'll see is that they talk about curvature of the universe, expansion of the universe. They talk about all this nonsense, Big Bang and so on, and they never define the word universe. So we don't have any idea what they're talking about. You would think that an important word like universe, is they're going to talk about the expansion of the universe, treating it like a physical object, right? The universe is expanding. What expands? A balloon? A ball maybe, a beach ball when you inflate it, one of those rubber rafts, you blow it and it expands. That's an expansion. You can expand something that's physical. So when they talk about the expansion of the universe, are they talking about what? A physical object? What is it that is expanding? That's the question you got to answer. Okay, so you can't find it in any of the official sites. I had to go to Stanford, find out if, the Stanfordians, the Stanford Encyclopedia of Philosophy, if they had any reference. They don't have the word universe. What they do have is cosmology, and they talk about, the philosophy of cosmology. And it says cosmology, the study of physical universe. Okay, great. So what is a universe? We don't know because they didn't define the word. Okay, so began as a branch of theoretical physics through Einstein's 1917 static model of the universe. Okay, as recently as 1960, cosmology was widely regarded as a branch of philosophy. In other words, the word universe did not belong to physics. Okay, it belonged really to philosophy. Only philosophers allegedly talked about the universe. It has transitioned to an extremely active area of mainstream physics and astronomy, particularly due to the application to the early universe of atomic and nuclear physics. There exists only one universe. Aha. I wonder what this multiverse stuff then is all about. So there is nothing else similar to compare it with. Okay? This means it is the historical science par excellence. It deals with only one unique object. That is the only member of its class that exists physically. Okay, so it's an object that exists physically. That's what these people say that the universe is. Okay, they're treating it as a physical object, not as an abstract concept. Okay, and so yeah, you say, okay, maybe it's just a solid thing, that you can kick like a table or something like that. Turns out when you look at the definitions that we have for the word universe, and remember we only define concepts, okay? We don't define objects. Objects we point to, concepts we define, okay? And so they define it, and so they defy the define notions, okay? They defy this because they should be pointing and saying that's the universe. They should give us a picture of the universe. And many times they put it beyond you. They say it's four-dimensional and you cannot imagine it, so that way they got rid of the problem, okay? Okay, so here you see all these sources, Wikipedia, Britannica, NASA, and Live Science, and they all give it a shot to try to define this word. But again, they don't do a scientific job on it. They just define it very loosely. Again, you can see they're all very similar. In fact, there is no difference between them. Essentially, some leave some parts out, some put them in. Like Wikipedia includes time and energy. Time is part of the universe. Energy is part of the universe. Two concepts. What do concepts have to be, doing? What are they doing within the container known as the universe? If the universe is a container, right? But see, they say it's space, time, matter, and energy. So that's essentially what the word universe stands for according to Wikipedia. Britannica does an even worse job because it gets rid of space altogether. They don't put they didn't even put space in there. Okay, they just put energy and matter and says therefore the human race is in there. And is that what the universe is? A place where we inhabit, like a house or something like that? NASA contains what? Energy. How can it contain energy? Energy is not a physical object. You can't contain energy because energy is a mathematical concept. Look it up and you'll find out. Energy is not a physical object. If it is a physical object, all you got to do is illustrate it for us. Put it on the table and so we know what energy looks like. Okay, and includes time. Also includes time in there. Okay, they put this concept in there. Okay, what does Live Science do? Well, it says it's everything. It's like God. God is everything. Okay, we solved the problem. Okay, if God is everything, God is nothing as well. And if the universe is everything, it's also nothing as well. Okay, and anyway, they include energy, everything you experience. Even all your experiences are part of the universe. So they just put all concepts that you can imagine, everything, every action. So we have no idea what the universe is because they never defined it scientifically. What is everything? Are you talking about God? Is that what universe is? Just a synonym of the word God, and God is everything. And again, what is God? God is a thing or a concept. Which one do you pray to? Do you pray to intelligence and love on the one hand, or do you pray to this man that's got a magic wand on the other and can grant your wish, a genie or whatever? So, you got to determine whether God is a concept or an object, and the same thing with the universe. Is it an object or is it a concept? And if it's an object, don't define it, don't tell us anything, just point. Okay, that's how you present an object in physics, in science. Okay, what is the universe comprised of? Maybe we can figure out from that, what the universe is. Well, these are the answers from general relativity, and I've just pulled a few. These are the most important ones, at least. Maybe there's a couple others, but we've already covered energy, time, sometimes space, matter, sometimes your behavior, your experiences. They put all that stuff in there, and they say it's everything. Great. We don't know what the universe is like that. Then we have other people who say it's events, dots known as points, also known as happenings. And one fellow who vouches for that is good old Mr. Stephen Hawking, who died a few years ago. An event is something that happens at a particular point in space and a particular time, so one can specify it by 4 numbers or coordinates. It is often helpful to think of the 4 coordinates of an event as specifying its position in a 4-dimensional space called spacetime. It is impossible to imagine a 4-dimensional space. Okay, so the way Hawking envisioned this, and I guess a lot of people would agree with him since he was a important guru in mathematics, and imagine it as all these little dots, and each dot represents an event and a happening. That's why I've got them moving, because they're not standing still. You would think that they're moving if it's a happening, if it's something that happens. Okay, so that's kind of weird that you would represent a verb with a dot. Okay, but this is essentially what he is defining, describing. Okay, so that's one way of looking at this. And there's what we covered last week. We covered the gravitational waves. Okay, and that's another way of visualizing what's inside the universe. Okay, and they look more or less like this. Where is it here? Give me a second. And here you have 2 black holes. They're twirling around. They create these waves in something they call space-time. Well, again, what is space-time? Well, space-time is another word for the word universe. Okay? So what is the universe? Again, we're trying to figure out what it's made out of. And they'll show you stuff like this, for example. Okay? I guess this would be Stephen Hawking's version. All these points, events, and that's what's waving. That's the best I can imagine. They never illustrated, so you got to do it for them. Okay, so if that's what space-time is, a bunch of dots that are waving, right? And so you have these 2 black holes, they collide, or they shake the space-time around them, and all these waves come all the way to us. So what is it that's waving? What is the universe comprised of? What does it consist of? That's the question we're trying to answer, right? What material thing is there? Okay, and here we have a similar version of that. Okay, this is space-time, right? And what is space-time? Well, it's just a bunch of, not even coordinates. What they are is number lines. Okay, you have the number line known as time, which is not a coordinate, it's not a dimension, it's not a vector. It's a number line. That's all time is. And space is also, they put the word space, which is ridiculous because they should be putting length, width, and height. Which is what they mean, but actually it's not even length, width, and height. What they're talking about are number lines. They're saying there's 3 mutually perpendicular number lines, which can't be the case because number lines don't have direction. They don't have perpendicularity. You can put numbers in any direction you want. Okay, in fact, they don't have to be in a line in any way, shape, or form. So what they're talking about is 4 number lines. That's what space-time is. And we can't say the 4 number lines are shaking, and that's what a gravitational wave is. So we've got a problem here. We got a problem because they're not identifying the physical object that's waving when they talk about gravitational waves moving through space-time or being the vibration, the oscillation of space-time itself, because space-time itself is just 4 coordinates, one of which is 4 number lines, one of which is number line time. Okay? So that doesn't help us anything. We're not talking about physical objects. We will not understand the mechanisms if we do not identify the physical objects. So far we got nothing. Here's another version, and that's matter, dark matter, dark energy, right? They have these things, and in between there they put these black holes and wormholes and other stuff in there. And this is more or less what they're proposing. Give me a second here. Here it goes. Okay, so we have a small percentage, which is the luminous matter. Then we have non-luminous matter, a little more. We have a lot of dark matter, 23%, and most of the universe is just dark energy, some stuff there called energy. And in between, they put black holes and wormholes. Okay, so this is the notion these people have of what the universe contains, what it's made of. Okay, this is what they're searching for. Okay, this is what they're trying to locate. I don't know how they can locate if dark matter and dark energy are admittedly invisible and intangible. which is their version of the word object, of the word thing. So here's a thing that cannot be touched or seen, and they're trying to locate it. How do they plan to locate it? Indirectly. They say if something moves in space, it's because there's some mass, a concept, not an object, just a concept, close by, a lot of mass that's moving it from a distance. So they never show you the mechanism. They just say it is so, mathematically. We measured, and that's what we came up with. And take it or leave it. If that's not a religion, I don't know what is. Okay, so we're still trying to figure out what it's made out of, okay? And we're saying it's made out of matter and space. That's all there is, okay? And here you have, by the way, in the case of dark matter, they sent this probe these a few days ago, the Euclid project run by the European Space Agency, and they are trying to locate the dark matter, that and the dark energy, by the way, as well. They're trying to locate this indirectly again because they say they cannot detect it directly. Okay, so again, these people believe that this stuff is out there, and this is what everybody on Earth, all the think tanks are searching and investigating, and that's what all your dollars are spent for them doing research on this inexistent dark matter, this inexistent dark energy, inexistent black holes, and inexistent wormholes. All that stuff that's out there that is invisible, intangible, that's what they're looking for. They're trying to prove it, get a Nobel Prize for proving their existence. And no, in science we say, look, it's very simple. What is the universe? We just need to define it. And we define it as this. That's what we see out there. And what do you see there? You see space and matter. That's all you have out there. Okay, that's what it looks like. That's what the universe looks like. No four-dimensional, no four coordinates, no energy, no fields, no gravitational waves, none of that stuff. All we have are out there are atoms that form big objects such as stars and planets, and space. And we don't have to use the word empty because space, by definition, is empty because it's not an object. It's not a thing. And a thing, it's what we call nothing, and nothing is that which has no shape because a thing is that which has shape. Okay, so it's the opposite. They're antonyms. Okay, so how do we do this in science? How do we get to the bottom of this in science, in physics? Well, we have to define words. That way we know what we're talking about. So we say that an object is that which has shape, and a concept is a word that embodies or invokes two objects or two words treated, temporarily as objects. And there you have the synonyms: relation, ideas, abstraction, comparison, etc., contrast. Okay, so object is to one what a concept is to two. Okay, so that's a good way of thinking about it. Mother Nature provided all objects. Humans invented all concepts. We invented the universe, meaning Mother Nature put the objects there, okay? And she didn't put them there, they were always there. Or Father Universe, one of those guys. But we are the one who established the relation between objects, the things like planets and stars, and the black space, the dark stuff that's around every object out there. And we have two things there. It's not a thing, space is not a thing, but we treat it, like it says there in the definition, we treat it momentarily as a thing. And we say, look, there's a comparison between two things, space and matter. And that's what the universe is. Objects we point to, concepts we define. So universe, we have to define. How do we define the word universe? Space and matter. That's what it is. And here it is. We put it in the universal movie so we know where exactly it fits. Okay, and it's a static concept. Okay, matter and space. And there you see it. That's the universe. It's not a dynamic. You don't have to see anything moving in the universe. You can take a snapshot of whatever's in the universe there, in a single frame. And what you'll have is just space and matter. And that relation is what you, the observer, the guy who's looking at that frame, that's what's in the frame. Even if you're not there, that's all that's in the frame. Okay, all you have there is space and matter. That is the definition of the word universe, and the word universe is a static concept. It's not a physical object. Therefore, you cannot say that the universe expands. You cannot say that there's curvature in the universe. You cannot talk about what's outside the universe because it's a concept. Okay? You can't. None of those things that mathematical physics does today can you do in physics. In math, you can do whatever you want because it's religion. You know, all that stuff is just calculations and measurements and followed by irrational explanations. In physics, we have to have a rational explanation for how this universe works so that everybody understands it. And what a lot of these people say is, well, we don't understand the universe. We cannot understand the universe. We do not understand Father Universe, right? Why? Because he thinks differently than we do. In other words, the argument is that our minds work a little different than how the universe works or how the universe is supposed to be, etc., how it is, etc. And all I can tell you is one thing, very simple, very simple. If God Almighty himself comes down to earth today, sits next to you, right? And he explains to you how gravity works, how magnetism works, you would understand how it works. You know, he's not going to bring any 4-dimensionality or 5-dimensionality or 26-dimensionality. He's going to say, look, this is how a magnet attracts another. We do not need 5 dimensions to explain how a magnet attracts another. You know, like this stuff. We do not need 10 dimensions to explain this. Okay? And likewise, we do not, if we have, my famous experiment, you let go of a pencil, right? Falls to the ground, to the table in this case. And so you got to answer, what is the mechanism? Hopefully we do not have to rely on 26 dimensions, 10, 11, 4, 5, or whatever. God should be able to explain it to you and say, look, this is how that's done. This is how I do this magic trick. That's how simple it is. It's baby stuff. It's all these mathematicians who went out there and say, we got to do it through measurement, we got to do it through equations, and they ended up with all ridiculous and irrational explanations such as bending of space-time and 26 dimensions and so on. And so, yeah, that's where we are today. Here we are, thousands of years since we started this process of trying to explain, especially gravity. Not a single mathematician on planet Earth can explain the mechanism of gravity.